See how it's dark over southern Missouri? That's actually the Ozarks. What we're looking at is a picture of the ground, just like you would see if you were at the satellite 22,000 miles up. So what we see on the visible satellite actually changes during the seasons, depending on what the crops are growing, trees are losing leaves, or whatever. This appearance actually changes a little bit. There is a little bit of weather going on, not much, I'm stretching it, but let me do this. Okay. Go back and look over Iowa here, look over southern Iowa and northern Illinois. You see much going on there? No, just clear skies. This is at noon today. Now I'm going to animate the satellite picture and watch what happens. See how the clouds form? See that up there? Also the clouds develop? That debunks one of the myths of weather forecasting. All you guys need to know what's happening in Denver, and a day and a half later it'll be in St. Louis. It doesn't work like that. Stuff forms right on top of you as you see there. Sometimes it's clouds, sometimes it's thunderstorms, sometimes it's heavy snow. But that's one of the things that we do in the weather forecast. So that's a visible satellite. We can put surface observations on there. So there's the latest observations. St. Louis, Columbia, Kansas City, Quincy. I can put pressure pattern on here too. And see this little kink in the pressure field? That's actually a cold front that's going to be coming into our area. And we're going to talk about that more in just a second. Okay, so kind of remember that cold front. This is a visible satellite picture. Obviously at night we don't have visible light, so we have to do something different. We use infrared imaging. The satellite has a sensor that takes a picture, quote unquote, of temperatures instead of visible light. So what you're actually seeing here is the temperature profile beneath the satellite. The yellows and the blues are actually cold clouds. Okay? And when you have a precipitation system that's being produced, the colder cloud tops usually means more intense precipitation. So, in the wintertime, we can use these colder cloud tops to really pin down where the heaviest snowbanks set in. In the summertime, we use the colder cloud tops to determine where this thunderstorm complex is getting really intense. That's the area that we worry about flooding and severe weather and things like that. If I go back to the start of this loop, which is during the pre-dawn hours, if you look over the Great Lakes, see how the Great Lakes are darker than the surrounding ground? That's because at night, the ground gets colder than the water. So you see that temperature difference there in the color gradation. If you look over eastern Wisconsin, see that dark spot right there? That's Lake Oshkosh. If you get close enough here, you can see Mark Twain, you can see Taneycomo, you can see Lake of the Ozarks, you can see Lake Shelbyville and Carlisle. And you see that because of the temperature difference between the ground and the water. Here is our radar data. This is what the radar display looks like from our workstation. The area inside the light blue is the county warden area that Mark told me about. That's what we are responsible for. Obviously, I put interstates on here in red and cities in yellow. The black dot is our radar out here. That's exactly the center of the radar, out in the parking lot. The only place our radar can't see is straight up. We have to use radar data from Lincoln, Illinois to determine storm severity here.
So you couldn't help yourself if something was
Not if it gets too close, no, we can't. And that's because the radar dish is on a tower like this, and it has to pivot. And it physically can't.
Have you got to turn in or something over there?
We do. It's in our copier room. So, but we can see them coming. We just can't see when they get out. Hopefully by then we're looking out the window.
Yeah.
I'm sure some of us will be. The light-colored echo that you see surrounding the radar is actually ground clutter. The radar beam doesn't go out at the pencil point, but it kind of fans out. And some of that fanning hits nearby trees and buildings and causes those returns that you see. The antennas that you see spoken out from the radar is actually interference caused by nearby cell towers. And we can put filters on the radar, and we're working on designing those, and those will be going away here hopefully in the next month or two. All the echo that you see here, the non-weather stuff, does not hurt us when it comes to storm detection. We can see right through that and see any tornado potential or anything like that. So I've shown you the surface data, I've shown you satellites and radar, and that's what we use for the short term of the forecast, the first 6 to 12, maybe 24 hours. And it goes like this. If I'm watching the storm, and the storm moves 30 miles in 1 hour, I see it's going to move 30 miles the next hour, 30 miles after that, 30 miles after that. In the short term, that's how we kind of forecast the weather. And in the short term, first 12 to 24 hours, that works pretty well. But after that, that breaks down. Just like, remember how those clouds formed over Iowa? Weather's not linear. It's always developing, always changing. And to kind of show you the complexity of that, here's another satellite picture showing you all the things that are going on over the northern hemisphere, North America. And this looks pretty complex, and it is. There's the nor'easter heading out. There's a big surge of dry air here. There's a weak low moving up into New Mexico, weak low over central Canada, another system coming down over the Pacific. To forecast the weather here, we have to track all that stuff. And it quickly becomes impossible for one person to keep track of after about the first 6 or 12 hours. So we use computer programs to get us in. And I bet you all of you have heard the term, Cindy or Dave or somebody use the term computer models.
Yeah.
The computer model is now saying that the snow is going to be south of St. Louis or whatever. Computer models is just a fancy weather speak for a computer program that helps us forecast the weather. Some very smart people, and let me emphasize, some very, very, very smart people have figured out that you can use mathematics to forecast the weather. So these guys write the equations, you take what's going on outside, put it into the equation, the computer starts to run, the computer says, okay, here's your forecast for tomorrow morning. Here's your forecast for tomorrow afternoon. Here's your forecast for Monday. Here's your forecast for next Saturday. Computer model. What we're looking at here is one of our computer models for 7 o'clock tomorrow morning. That cold front over Iowa is forecast, this model is forecasting that to you right here. The blue is pressure, the red is temperature, and the shading that you see is the computer's best guess about where precipitation will occur. So if I base the forecast for St. Louis on this particular model, I will tell you that I think the front will come through here just before 7 o'clock. It should come through here with no rainfall, and temperatures tomorrow should be cooler in northern Illinois, northern Missouri, and Iowa. So that's how we forecast the weather. That's all there is to it. No. Now the rest of the story. If the computer models were always right, this would not be a hard job, but they aren't always right. The models make basic assumptions about how the weather works. Sometimes those assumptions are correct, sometimes they aren't. Some models are good in the spring, some are good in the winter. Some are good in the short term, some are good out days 3, 4, and 5. Our job here as meteorologists is that we look at all the computer models, and what we try to do is pull out the most accurate stuff from each computer model, put that into a forecast, and we give to you all. And that's basically how we do our job. Now back in the old days, when we come up with what we thought the weather would do, I'd type it up. Today, sunny, tonight, clear, whatever. There was a lot of typing, and I didn't do much forecasting. So nowadays what we do is, we put our forecast into what's called a digital database. And this is our graphic forecasting. It looks very complex, and it kind of is. But every gray box you see there is a forecast element that we are forecasting. So for instance, what we're looking at right now is the high temperature forecast for Wednesday. Here's the temperature forecast for Tuesday. Here's the forecast temperature for Monday and for tomorrow. High and low temperatures, 7 days out. Temperature, dew point, wind, humidity, sky condition every hour, 7 days out. When you go to our website to get our forecast, you aren't accessing something that we've typed or something we've created. What you actually access is this digital database. So for instance, if you go and you want to look at the forecast for Washington, Missouri, you click on Washington, Missouri, and this comes up. And this little picture thing, forecast at a glance, detailed 7th forecast, that all comes right out of that database. Your computer says, go to the Weather Service. The Weather Service says, oh, I see your request. I'll look at the digital database. Here's your forecast. That's how it works. You need something a little more sophisticated, you can get an hourly weather graph that looks like that, or a tabular forecast that looks like that. We don't type hardly anything anymore as far as forecasting goes. it all falls out of that digital database over there.